Let's solve this 2024 JMO problem 1. Let ABCD be a cyclic quadrilateral if AB is equal to 7 and CD is equal to 8. Points P and Q are selected on segment AB such that AP is equal to BQ, which is equal to 3. Points R and S are selected on segment CD such that CR is equal to DS is equal to 2. Prove that PQRS is a cyclic quadrilateral. To do this, we use power of a point. There's actually two solutions. One is longer by doing two cases. If AB is or is not parallel to DC, then using power of a point. But here I'm going to present the faster solution. So let's just say that the center of the circle that ABCD is inscribed in is like a point O. And so basically, we want to prove that OS is equal to OR is equal to OQ is equal to OP. And so, okay. And so now to do this, we use power of a point. So the power of point S in respect to the circumcircle of ABCD, which we'll call omega, it's going to be equal to negative 2 times 6, which is equal to negative 12, because it's going to be 2 times 6. And then since S is inside the circle, the power of point S omega is going to be negative that, which is negative 12. And similarly, the power of point R is going to be negative, since R is inside the circumcircle of ABCD, 2 times then 6, which is also negative 12. And similarly for P, it's going to be 3 times 4 and negative that since P is inside. So it's going to be negative 12. And for Q, similarly, it's going to be 3 times 4, which is negative 12 after negating. So then the power points P, Q, R, and S all are the same in respect to the circumcircle of ABCD. That's interesting. Okay, but how do we use this to prove that a PQR is cyclic? If you're familiar with PowerPoint, this is a theorem, but let's just prove it since it's not too difficult. So the power of point S in respect to circle omega is going to be equal to OS squared minus R squared, where R is the radius of the circumcircle of ABCD. So for example, AO is R. And this is well known. And so OS minus R squared is equal to negative 12. And similarly, OR squared minus R squared is equal to negative 12. And so on all the way until OQ squared is equal minus negative R minus R squared is equal to negative 12. And so then from this, we know that OS squared is equal to R squared minus 12. OR squared is equal to R squared minus 12. And similarly, all the way until OQ squared is equal to R squared minus 12. So then OS is equal to R, OR is equal to OP is equal to OQ. And so a point O is equidistant from each of the points P, Q, R, and S. And therefore, P, Q, R, and S is inscribed in a circle with center O. So we're done with this. If you like this video, please like and subscribe. Thank you.